You have probably already seen the ring system of a gas planet J1407b that supposedly has the biggest rings in the universe. Well, this is a huge misinformation, and the planet J1407b is not what the internet thinks it is. Let's dig deeper together with us into this magnificent planet that we thought had this huge ring system. For short, there are several studies proving that this planet is not real at all, and professional astronomers know that J1407b does not have this ring system for years now. But why do we still think that this planet is real? Space-related YouTube channels are still making videos about it. Basically, the files that confirmed that this planet does not exist are not known by many people as the videos on the internet. Another thing is that Googling planet J1407b does not give you any results that it might not exist. More likely, it will tell you that this planet is real and everything is true. People spread this misinformation online, and now it's hard to even tell it's not real. The object that transited in front of the star V1400 Centauri, which we thought was a planet with an extremely large ring system, has turned out to be a rogue brown dwarf. This brown dwarf that is still called J1407b is an object between a planet and a star in size, with a protoplanetary disk where new planets are actively forming. If you want to know more, there is a longer video about this case in the description.
How do you go to the bathroom in 0G?
Have you ever thought about how astronauts use the toilet on the International Space Station or on rocket to the moon? In the spacecraft environment, using the toilet is a unique challenge for astronauts. To accommodate this, the space toilet is specially designed with a system of airflow to direct waste into appropriate receptacles, ensuring nothing floats away. For solid waste, astronauts use a small seat with thigh straps to stay securely in place, and the waste is collected in sealed bags, which are later compacted and stored for disposal. For liquid waste, they use a funnel attached to a hose, which is connected to a vacuum system that pulls the urine into a storage tank. However, during a landing mission to the moon, this equipment wasn't so advanced. Apollo astronauts had to pee in a roll-on cup, and for solid waste used a bag attached to their spacesuit. But don't worry, all of the waste was then taken back to Earth. In the year 1054, a huge light appeared in the sky, visible even during the day for several weeks and during the night for 2 years. This celestial event, observed and recorded by astronomers from various cultures, was the explosion of a massive star in the constellation Taurus. This supernova, known today as supernova 1054, resulted in the creation of the Crab Nebula, a cloud of gas and dust expanding outward from the site of the explosion. Supernova explosions are relatively rare events in our own galaxy, happening once a century or so on average. The event is a vivid reminder of the cosmic forces at work in the universe and has been a cornerstone in the history of astronomy. Now let's look at the life cycle of some stars. We know that stars are born in the cold, dense regions of space known as molecular clouds. A disturbance, like a supernova shockwave, triggers parts of the cloud to collapse under gravity. As the gas and dust compress, they form a protostar, which heats up and gathers mass. When the core temperature reaches about 10 million degrees Celsius, nuclear fusion ignites, converting hydrogen to helium and birthing a new star. This young star clears away surrounding gas and dust, revealing itself as it begins to shine brightly in the universe. The remaining material can form planets, leading to the potential creation of a new solar system. We need to understand that a star's life cycle can reach up to billions of years, and all of this is happening in its time. Now, let's split stars, depending on their mass. First of all, we have low mass or average stars. They usually have somewhere around 13 Jupiter masses. As the star starts slowly fusing all of its last hydrogen in its core into helium, things begin to change. The core will shrink and get hotter until it becomes a red giant star. After almost all the hydrogen is gone, the core gets even smaller and even hotter. This time, the star is getting slightly bluer and even hotter. When the star has very little material to burn, the core collapses, growing rapidly fast until it becomes a giant star, again leaving an Earth-sized core in the middle. This core will then cool down until it becomes a white dwarf star. The ejected shell is then called a planetary nebula. There is an interesting fact about the white dwarf that we can't confirm or deny. Scientists say that when a white dwarf cools down, it can become a black dwarf, a final stage of a star's life that no longer emits light or heat. However, this cooling process would take billions and billions of years, and the universe isn't there for that long for any of the black dwarfs to form yet, or we just didn't find them. Now move on to high-mass stars, ones much more massive than our Sun. Due to fat fusion, those stars are hot, big, bright and blue when they form. For a definition, high-mass stars take millions of years to run out of fuel. However, small-mass stars take billions. When the star begins to run out of fuel, the core gets smaller and hotter, producing more energy, swelling up into a giant star. The core gets still hotter, and the star becomes able to fuse helium nuclei to form carbon, oxygen, neon, and silicon. At the center sits the heaviest of them all, iron. Until no fuel remains, the star is left with a core of iron nuclei. The core is then so stable that further fusion can't release more energy. At this point, gravity takes part, and the star collapses and shrinks within a single second and explodes. This is the death of a star we call a supernova, one of the most violent phenomena in the universe. Speaking about supernovae, let's look at their types. There are two types of supernovas. Shortly explained, Type 1 supernova occurs when a white dwarf, a star that burned all of its hydrogen, steals material away from a nearby star until it can no longer sustain its own weight and blows up. This supernova is way brighter and rarer than the second one. We already know about the second supernova, as we spoke about it earlier. The cool thing about supernovas is that despite the fact that the core collapses in a quarter of a second, the shockwave takes a few hours to reach the surface of the star, a few months to brighten, and can be visible for a few years until it fades away completely. In 2019, we achieved something we wanted to achieve for years. The first image of a black hole was taken. However, it wasn't just an image, it was a breakthrough in our technology and understanding. Let's dig deep into the birth of this image that wasn't easy to get. For short, black holes can't be detected since they emit no light unless they are eating. Throughout one galaxy alone, there could be hundreds of smaller black holes. But one is always unique. In the center of every galaxy, there is a massive black hole that keeps everything together, spinning everything around. In 2019, scientists were able to create a real picture of a black hole using math. By using individual 8 telescopes placed all around the globe, they indeed took 2 pictures of a black hole. First, they imaged Sagittarius A, a black hole in the middle of our galaxy, and Messier 87, a black hole being nearly 54 million light-years away. The 8 telescopes sent unique radio waves to so-called the event horizon. By combining their frequency and series of white and dark fringes, they got white fringes from telescopes that are close together and dark from those that are far away from each other. By combining those patterns, you get a dark and white image of a real black hole. Then, just add a color from the chemical side of view, and the first images of black holes are born. Thank you for watching and subscribe for more content from our universe.